So this is the ALM System Coupe. This is an 84 HP modular system from ALM, and it comprises some of their kind of most well-known modules, something like PAMs, and then also some newer modules, Squid, and then some unique modules, so the MCF, Milton. These are unique to the system. So you can think of the system as dividing into two kind of distinctive sections. We have the modulation kind of control section over here, and then on this side we have sound generation, sound manipulation, and all that kind of stuff as well. So let's jump into some patches. You can hear a bit of it. We'll go through the different features and what hopefully get some nice sounds of it, and see what we can do with it. So first of all, let's just have a look at the MCO and the MCF. So this is the oscillator and the filter section of the system. We're just going to ignore the Squid for a moment, and we'll just listen to the oscillator and the filter. So we have our main output. So the oscillator has three outputs. It has this standard wave output. So this is the wavetable output. And we've got various different waves across this knob here. And then we have this pulse wave output. So this is kind of the most interesting, I suppose, and this fairly unique feature to the MCO is this ability to pulse width modulate all of the different wavetables. And we also have this type input here. Type will give you kind of different number of different kind of pulse points within the pulse width modulation. So if we add a slow moving LFO to type, we get this kind of nice, interesting kind of almost sounds like octave switching. That's because it's adding more pulse points within the pulse width modulation. And then we could also add an LFO to the pulse width modulation as well. You can hear it goes all the way through 0 there. So maybe I can reduce that slightly. Pounds over here, so I can change the level of any of these outputs. I'll go into the level output here. Might be quite difficult for you to see that on the camera there, but we will go through that. So we can really dial in the modulations to exactly where we need them on PAMs. So yeah, you can see that there's really kind of interesting flavors of pulse width modulation there. And then finally we just have a subwave output, so 1 octave down. A useful feature, but nothing too crazy special. So let's move on to the MCF. MCF is a multi-mode filter. So I'm just going to take the subwave output, square wave, so you know exactly what's coming into the MCF here. So let's just take that. And we'll start with the low pass here. And MCF is resonant, so if we take out the input here, We do get a sine wave oscillator as well. We've got volt per octave in here as well, so we could use this as a second kind of sine wave oscillator. Useful. So moving on to the other outputs. So we have a notch slash bandpass. I've got this jumpered to be a notch at the moment, so let's just listen to that. So take that down. And then we have finally this high pass output. But maybe if we get something a bit more kind of fruity going on, so we can add this pulse width modulation in again. Go over to the notch. We're listening to the pulse width output here. Low pass. Get some modulation going on that filter there. It's a attenuverter. So we've got CV input for frequency here, but also for resonance. But yeah, you get the idea. We've got a kind of nice, interesting sounding oscillator here. So let's just go through the control section over here. So we have MIDI to CV. Simple, comes in on 3.5mm jack. We have 2 channels of CV and gate with velocity. We then have a clock output, or a kind of DIN sync really, because it's times 24 clock, and then a run output. So this is useful for clocking Pamelas. Next to here we have the trigger outputs. So these are specific note gates and triggers. So next up we have Pamela's new workout. Pamela's is an 8 output modulation source, clocked modulation source. So for each output we can adjust a number of different parameters, but we can do all sorts of things, LFOs, random voltage. We've also got built-in quantizers, so we can quantize those modulations as well, envelopes, Euclidean stuff, looped random. It's mind-boggling the amount of stuff that you can do with Pamela's and the amount of detail that you can go into for each individual output. But it's not very nice to play with on the fly. So that's where Quaid Megaslope comes in. This is more of your hands-on kind of modulation source. So if we put a gate in, we can use it in 3 different modes. We've got envelope mode, a looping mode, and a step mode. So in envelope mode, this set button here will set where we're going to sustain from. So if we put a gate in and hold the gate high, it's going to now sustain on this step because we've got this set. Now in looping mode, the set button here controls where we're going to loop from. So now we're just looping these 3 stages, and now we're looping 5. So you kind of get the idea. And then we can have in step mode, so then a gate would step through. It would be like a 5-step sequencer. So that's our kind of modulation section. So let's just have a look at sampling in Squid. We've got this kind of noisy patch set up. So if I hit monitor like that, now we can hear what's coming in. You can see my gate signal here, and this is what I'm going to use to automate the recording. So let's just stop that for a second. And now we've got this kind of noisy patch going on, and we're going to take the gate output to come into the record here. So if I hit record, we've got various different ways that we can use, that we can sample. So we can replace, overdub, or extend the recording. So we're going to use extend here, and what we're going to do is we are going to automate this recording. So if I take my gate signal, go into the record input here, now if I press start on my thing, it's going to basically create a new sample or a new cue point within that one channel every single time that we get a gate signal. So now I go to my cue points, you can see my sample here. We can zoom in and, you know, do what we need to do, but we have all these different cue sets. So these are just basically start and end points of the samples. So you can see how we can use this to then resequence these as we wanted. So another thing that we can do is take that same gate signal that we've got coming into the record here, and if we go into channel, then now this is going to, if we put this on replace, so now when we hit start, it's going to go through each different channel and record a sample to that channel. So now you can hear my different patch across each different channel. So this is just a couple of different ways that we can record or sample into the sampler. Other things that we can do is we've got we can split, and we can also automatically kind of find transients and cut things like breaks and stuff like that. Or say if you were to record a bunch of one shots from a drum machine or from your computer, you could just put them in, then automatically split those, so that then or automatically kind of cue point them, so we can then have a different set of cue points, so start and end points per channel. So even though we only have 11 seconds of sampling per channel, we can get a lot out of it by using cue points and start and end points and stuff like that. So yeah, that's a quick look at sampling in the Squid. So the idea with this patch was to use the Squid and the Coupe as a kind of remix palette, if you will. I took samples from a track on the new EP that I've got out in December. Maybe that'll be out by the time this goes out, but not really sure yet. So I took some samples, and I'm using a Digitact to sequence this. If you listen to the original track, the bass line is kind of really like what carries the whole tune, really. I've actually pitched it down here, so this is the original bass line, so it's actually an octave down, because I've got this number 6 here quantized to octave. So you can quantize these volt per octave inputs either by semitones, no quantizing, or octaves. And then I've got this kind of noisy kind of thing which is running through the delay here. That's from the MCO. And then finally we have these two things. So this is a kind of texture from the original track. I'll just take out the MCO for a second. That's coming in, so 7 and 8 is coming into this mixer, as well as this MCO is coming into this mixer here, the Unity mixer, and then they're both going into the filter. And then the bandpass / notch output is coming out into the delay here, and then back in through the line to Euro converter. And then if we go to holding channel, go over to number 8 here, to channel number 8. So unmute that. So this is this kind of plucked kind of texture thing. and I've just got that being re-triggered, and I've got various different cue points, and I'm using a control voltage to move through the different ones. But yeah, that's kind of just a little way of kind of using this as a kind of remix box, really. So let's have a look at this feature of Squid, which I didn't know it could do until just now. This is a fairly, I think, useful feature for when you're working with breaks or samples, or like drum samples, stuff like that. So I have these kind of 4 channels set up to play back some kind of jungle breaks. So channel 1, this is looping in gate mode. So if I play it from here, it's just going to loop forever. But if I play a break, a trigger from my sequencer, the Digitact over here, if I hold it down, it's going to keep looping. But if I just tap it, obviously it's just going to gate the loop. And then channel number 3 is just, so this is a set of 1-shots. And I've got them randomly kind of stepping through every time it gets a trigger. So just randomly go through them. And obviously this is all sequenced via the Digitact. And then finally, channel number 4, we have some more kind of breaks. And again, we're on loop mode here. So what the feature that I kind of thought was quite useful is that Squid can actually kind of approximate a tempo. So at the moment this is running at 165.5. So I have my kind of break set up to be sequenced from the Digitact. And I'd like to say slow this down. So I'd like a much slower kind of break. And obviously I can do this with pitch, but I don't have any kind of assumption. I don't know how fast that pitch is. I don't know what the tempo of that is. Now what we can do is we go to the speed of the sample playback. At the moment this is at whatever it was recorded in at. And if I hold function, I can see the BPM and then slow it down. So say I want to go to 140. So now that is playing back at 140. So if I go through all of my, so also this is another kind of useful button combo. Holding channel and then twisting the encoder will move to that same page on the different channels. So now I'm on number 3, and this again is making the assumption of that. So we can go to 140 again. So here. And channel 3 obviously is just 1 shot, so we don't really need to do that to that one. And then channel number 4, again, we can go in and adjust the speed of that. So now if I press play, we should have everything playing back at 140, albeit at a slightly lower pitch because I've changed the pitch of the samples, or the speed playback of the samples, but so yeah, that worked. And I think that's a really useful feature. So here's a little kind of baseline that I've developed on those breaks, and I kind of wanted to do this just to show off the CV inputs on PAMs and how we can really manipulate the outputs of Pamela's new workout with the CV inputs. What I've done with this patch, so a long hold just gets back to this kind of front page. So what I've done here is taken output number 1 and we've made an offset by just offsetting the whole of the output by 100%. So when I hit play on my sequencer here, or when Pam starts, this is gonna output number 1 is going to be constant because the offset is set to 100 here. So yeah, so that's what output number 1 here is doing. Output number 2 is just a gate signal that's going to be gating that baseline, as you saw then. So this is the envelope that I'm using for the voice. The voice is the MCO into the MCF. And so then 3 and 4 are going to control the pitch of the oscillator and some modulation of the filter. Output number 5 here is doing some pulse width modulation, so we can hear that at the moment if we open up the filter bit. So you can hear that modulation. Now what I've done is taken this offset, put that into the attenuator on Milton, and then as I raise the attenuator on Milton, what it's going to do is if you look at output number 3 and 4 here, currently they're doing nothing. If I go to those, we go to the level, and that's being controlled by CV out input number 1 here. So as I raise my offset, which is output number 1, which is being attenuated currently, if I open up that attenuator, so output number 4 is some random modulation on the filter, and output number 3 is a quantized melodic sequence, and the level of that is being controlled by that attenuator. So now also what's happening on output number 5 is if I raise it all the way, we no longer get you can hear we no longer get the pulse width modulation, and that's because what I've done is on output number 5 here, so go back, output number 5, and go in here, we can see that the level of that is being controlled via the CV input number 1 again. But what I've done is if I highlight that and then hold again, we can actually go into each individual output or whatever we're CV controlling, and we can offset and attenuate the incoming CV positively or negative. So I've negatively attenuated the output of number 5, or the level of number 5, with that offset from number 1. So as I raise that, as I raise the offset, it's actually reducing the level of output number 5, and so we're not getting any pulse width modulation. So anyway, yeah, that was kind of just an idea to kind of show off how kind of deep PAMs can get, because it's really, I mean, in my opinion, one of the most deepest modulation sources. It can be a little bit fiddly, kind of going back and forth like this and using just this one knob, but it does work, and it works really, really well. So overall, I think that the System Coupe is a really good introduction and showcase of ALM's modules. It's really fun to use, and it does kind of have everything that you might need, bar some effects. You know, if you're a new modular user and you got this as your first system, you're not going to be disappointed. And there's two kind of things that you really need to learn and kind of get deep with the system, and that's the Squid and PAMs. Both of these modules are really deep. Everything else is kind of fairly standard, you know, this is just fairly like subtractive synthesis area kind of here, and the envelope, although it's fairly non-standard, it can be used in standard ways, the Quaid Megaslope. I think you can pick it up for around 1899, so yeah, it's pricey. It's a really expensive modular synth. But then if you were to buy all of these modules together with a case, you'd be looking at way more than that. So overall, I mean, I think this is a great little system, and you can really make tunes with it, you know, as long as you've got a decent sequencer.
I would find it hard, yeah, as I said, without the MIDI to CV, because I like to make things that can have some repetition, but you can do loads of weird generative stuff with this as well. So yeah, it's a big thumbs up from me. I'm definitely into the ALM System Coupe, and it is fairly non-standard, it's fairly weird, but if you're looking for something that's unique and interesting, then yeah, I think you wouldn't go wrong with the System Coupe. So yeah, thank you very much for watching, and see you next time.
So if you're interested in any additional content, we do have a couple of patches up on the Patreon where we explore some of the deeper features of both the Squid and the System Coupe.